All matter can be classified as either a pure substance or a mixture. Pure substances include elements and compounds, and mixtures can be homogeneous or heterogeneous. But what exactly do these terms mean? Let's find out. Pure substances include elements and compounds, and they can't be broken down into simpler substances by physical means. Okay, so physical means are things such as melting or boiling. Elements contain only one type of atom. Elements include lots of substances that you've probably heard of, like oxygen, carbon, and gold. Scientists have a very special table that lists all the different elements that we know of in a systematic way. So it's called the periodic table of the elements. We'll learn more about this very important tool later. Compounds, on the other hand, are made of two or more types of atoms that are joined together. So an example of a compound is water, which you may know of as H2O. So what it's saying is that water is made up of hydrogen, which is the H, and oxygen, which is the O. We can't break it down into these elements through physical means. It's always stuck together, and whether I boil it, freeze it, or melt it, the hydrogen and the oxygen don't separate. Water will always have a fixed composition too. It's always H2O, so there are always two hydrogen atoms for every oxygen atom present. All pure substances share this property. Their composition doesn't vary. When compounds form, the elements that make it up completely change their appearance. For example, sodium is a really reactive metal. It'll explode in your hand, catches fire just when added to some cold water. Chlorine, on the other hand, is a yellow-green, highly poisonous gas that was used in World War I to kill people. But when you put them together, you get sodium chloride, which is common table salt. The compound sodium chloride is quite unreactive. It's nothing like the sodium metal that it's made up of. And because it's a compound, it's impossible to break sodium chloride back into exploding metal sodium and poisonous chlorine gas through physical means. So you can't try and melt it or boil it, it won't work. Mixtures are different to pure substances. Unlike compounds, they don't take on an entirely new appearance or properties when two or more components are combined. A mixture is just that, a mixture of its components. For example, a mixture of dirt and water might have a lot of dirt and a tiny bit of water, like wet dirt, or it might have lots of water with a tiny bit of dirt, or anything in between. The dirt and the water still look and behave like dirt and water. It's easy to separate it out by physical means. Just tip the water off, filter the dirt, dry it out. Mixtures can be further divided into homogeneous, which means it looks the same the whole way through, and heterogeneous, which means the mixture looks different throughout. Dirt and water would be classified as heterogeneous. Salt water, on the other hand, would be classified as homogeneous. Homogeneous mixtures are known as solutions in chemistry. And here's another example. Milk is a homogeneous mixture. It's got mostly water, plus some protein, some calcium, some fat, and other stuff in it. They're all separate in the milk and can be separated out, so it's classed as a mixture and not a compound. And milk is homogeneous. The label even says homogenized. It looks the same throughout the whole thing. However, if I add some Milo to it, it dissolves a bit, but some of it stays floating on the top. The properties haven't drastically changed by combining the two. It's now milky Milo. This is a heterogeneous mixture. It looks different at the top of the glass to the bottom. So that's how we classify matter into pure substances and mixtures.